Hubble Cable Accessories and Product Training 101. This video is an I would like to begin by thanking everyone for joining Hubble Utility Solutions in this video called Hubble Cable Accessories and Product Training 101. This video is an introduction on the definition, purpose, types, and uses of cable accessories. In this presentation, we will first begin by covering content on what are cable accessories, then transition to the common types of cable accessories and their components. Next, we will talk about cable accessory applications with an overview of the history of underground distribution and conclude with a brief introduction to Hubble's product offering. All cable accessories fall under two main categories: dead front and live front. Equipment is considered to be dead front when the operator is not exposed to any high voltage parts. To maintain dead front criteria, all connections must be protected with rubber and all voltage carrying parts cannot be exposed. Live front means that high voltage parts will be bare and poses as a safety hazard. For this reason, utilities are transitioning more towards dead front equipment when available. All Hubble underground separable connector products are dead front. From there, cable accessories can be classified by dead break and load break. Load break products can be operated while the cable is energized and carrying load current. Dead break products can only be operated when the cable is de-energized. To start off with the basics, cable accessories or underground separable connectors are mainly for underground applications. You may have wondered what are inside those green boxes that you often see in neighborhoods and large shopping centers. Cable accessories are rubber molded products that are found inside the large green boxes, usually seen on the side of the road in your neighborhood or near a large building. Underground cable carries current to these boxes that contain switchgear or pad mount transformers that step the voltage down to a level that you can use in your house. When the cable comes from underground, there needs to be a way to connect to the transformer or switchgear. This is the job of cable accessories. These products are designed for utility line workers to safely work around and operate. There are many types of underground separable connectors. One of the most common is an elbow. Elbows have three major components: the cable entrance, operating interface, and probe. The cable entrance is where the underground cable fits into the bottom of an elbow with a connector that makes contact with the probe. This probe extends outside of the elbow's interface, similar to a plug. The operating interface is the size and shape that this plug can fit onto. Pad mount transformers typically have anywhere from 2 to 6 elbows inside. Some transformers only have one, some may have more than 6. Enclosures and switchgears can have up to 12 or more. Just picture a large power strip. Another common underground separable connector is the bushing insert. Like the name implies, the bushing insert screws onto a bushing well in a transformer or switch. It's common for bushing inserts to be pre-installed in these cabinets. The bushing insert's primary components are the interface and its copper contact. The interface is important because it is what the elbow was sealed onto. The copper contact is there to make the electrical contact with the probe, feeding electricity from the cable into the transformer or switchgear. The bushing insert acts like the outlet you'd plug your household devices into. The elbow is the end of the cable that travels underground, and the bushing insert is installed in the transformer or switch. The image on the screen shows how these products and components we discussed earlier fit together. You may ask yourself, will I ever see these products if they're underground? The answer is, you probably never will see the physical products, but you will feel their impact. Cable accessories are all around you, but they are tucked away in green boxes you may see at a shopping center or neighborhood that doesn't have any visible overhead lines. Not only are these out of sight to improve aesthetics, but this also keeps the public safe. In this image, you can see the intention of underground distribution with houses that have hidden underground lines versus each house having a utility pole in their backyard. Instead of a pole, you would see a green pad mount transformer with the inserts and elbows that we discussed earlier. That transformer is then connected to a feeder line coming off of a distribution line. The transformer can provide enough power for up to 10 houses. This is why you might see multiple transformers on the same street. Solar and wind farms also use a lot of cable accessories. They help get the power from the panel or turbine to the substation so it can be distributed throughout the grid. Without cable accessories, our overhead lines can't go underground. These products provide a safer means of operation for line crews to connect underground cable to transformers and switchgear. Cable accessories are designed to allow for the safe operation of switching and cable terminating, so line workers can perform maintenance and repairs on energized lines without having to cut off power to end users for long periods of time. Similar to your house having switches and outlets, cable accessories provides a means of distributing power throughout neighborhoods and businesses. Underground utilities can raise property values as safety, reliability, and aesthetics are significantly increased when you take overhead lines underground. Underground lines aren't negatively impacted by wildlife and can handle severe weather events such as hurricanes and wildfires much better than overhead lines. Hubble doesn't make cable, but we need to understand underground cable before we can really understand cable accessories. In this image, you can see the difference between overhead and underground lines. Overhead lines enjoy the ability to use increased space and air as an insulator. But with underground, you don't have that luxury of space. If it's buried, it has to be insulated. A few of the most important factors in underground cables are insulation and shielding. A medium voltage line must be properly insulated and shielded in order to minimize electrical stress and losses. As voltage increases, so does the cable insulation thickness. Cable accessories are size-sensitive products in the way that their interfaces fit together and the way they fit onto cable. When sizing our elbows, we need to know about the conductor type as well as the insulation and metallic shield type. The conductor center is either made of copper or aluminum. This is where the cable carries current. Conductor type can be stranded, compressed, compact, or solid. The insulation insulates the conductor from ground and other conductors. As the conductor size and voltage changes, so will the insulation diameter. Metallic shield type can be concentric neutral, copper tape, or longitudinal corrugated tape. These are some of the more common metallic shield types. The metallic shield provides a path for fault and circulating currents to return back to its source. As mentioned earlier, conductors can be stranded, compressed, compact, or solid, which can impact the overall conductor diameter. Most elbow kits come with a connector, so it is important to know which conductor type is being used to ensure the correct connector is selected. For example, the 1/0 stranded and 1/0 solid cables have two different diameters. Both require connectors to provide a reliable connection. Choosing the wrong size connector can cause heating and lead to thermal failure. Selecting the right elbow also requires information about the cable's insulation diameter. The elbow's housing cable entrance creates an interference fit with the cable insulation to provide dielectric strength and prevent moisture ingress. Typical insulation thicknesses are 175 mm 100% for 15 kV, 220 mm 133% for 15 kV, 260 mm 100% for 25 kV, and 345 mm 100% for 35 kV. Finally, the elbow's operating interface has specific dimensions based on the voltage class. The elbow and the mating interface should match according to their voltage class. For example, a 15 kV elbow mates onto a 15 kV bushing insert. Now that we know how the elbow and bushing insert fit together, let's take a closer look at their individual components. To begin, on the elbow is the operating interface, which is defined by IEEE standard 386 as either 15 kV, 25 kV, or 35 kV small and large interfaces. As previously mentioned, this interface must match the mating product's interface in order to achieve a good connection. The interface has an interference fit seal when installed. It provides proper creep distance and a watertight fit, yet permits unplugging of an elbow after years of service. The probe mates with the finger contacts, also known as tulip contacts, on the bushing insert or other switch point. The inner end has threads and the outer end is made of an ablative material that produces gas when exposed to load break arc, permitting reliable interruption even with close ground spacing. The cable entrance has conductor rubber stress relief area. Load break bushing inserts make installation in the field quick and safe. Installation made with molded EPDM rubber and an interface that conforms to IEEE standard 386. When a suitable elbow is installed, it provides proper creep distance and a watertight joint. The load brake assembly includes an ablative material that produces gas when exposed to load brake switching, which allows for safer switching when used with elbow load brake elbows. The seating indicator helps the installer to identify when the mated part has been seated completely. Tool of contacts are part of the load brake assembly, which has an all-copper current path. The piston assembly is a patented concept. Piston movement assists operator under fault-close conditions. The hex feature accepts 5/16 hex wrench for proper torquing into the bushing well. Next, we will review a few other cable accessory products and their applications. Insulating caps are used to cover unused, energized interfaces to protect them from elements. These provide an insulated and shielded cover to protect line workers nearby. Like the elbow we discussed earlier, insulating caps also have a defined interface based on its voltage class. The most common place for an insulating cap is on an unused interface of a junction. Junctions are similar to the power strip you might use at home or in the office. They provide multiple interfaces for additional underground cables to be connected to. Junctions are usually found inside the fiberglass or metal enclosures, also offered by Hubble Utility Solutions. Junctions and tap masters, which we'll discuss later on, can have anywhere from 2 to 6 positions or interfaces. Along with elbows and insulating caps, this is where you may find elbow arresters. Underground arresters provide overvoltage protection to underground systems. There are a wide variety of cable accessory products. The two most common are the elbow and parking stand. Elbow arresters look similar to the elbows that we discussed earlier, but house the MOV metal oxide arrestor module inside of the body. The parking stand arrestor provides an additional interface for elbows and take up less space inside of a cabinet. The 600 amp 25/28 kV dead brake T-body offers an easy and reliable method of terminating and splicing main feeder circuits. The dead brake T-body is fully shielded molded rubber. T-bodies are the 600 amp dead brake version of an elbow. This connection is bolted together to be able to handle more current than a regular elbow, which is why it cannot be operated energized. T-bodies are also size sensitive, but use cable adapters to fit onto different sizes of cable instead of changing the elbow size. Another difference between the load brake elbow and the dead brake T-body is that the T-body uses a threaded stud instead of a probe. While underground cables were first designed in the late 1800s, it was not until the mid-late 1900s that enough advancements were made with underground cable and cable accessories to be able to provide a reliable underground network. Lady Bird Johnson was a proponent of the Highway Beautification Act of 1965. While the focus of this was intended to encourage the scenic enhancement of roadside development, this also helped accelerate the acceptance of underground utilities. Hubble has been manufacturing cable accessories since 1999. Today, Hubble Utility Solutions offers a full line of 15 kV, 25 kV, and 35 kV class underground separable connectors for 200 amp, 600 amp, and 900 amp applications. Our underground separable connectors are designed and tested to meet or exceed all applicable requirements of IEEE and other industry standards. These underground separable connectors are fully interchangeable with competitor products, fully shielded, insulated, and fully submersible up to 6 feet in water. Our 200 amp load brake product line includes load brake elbows, junctions, feed-throughs, and bushing inserts. We can also provide customers with insulating caps and fused elbows. The Hubble 600 amp and 900 amp products are available for 15, 25, and 35 kV systems. These are often network feeder lines found in commercial and industrial applications, as well as in power generation systems like wind and solar. Dead brake separable connectors are bolted together and cannot be safely operated while energized. All Hubble products maintain a dead front status, so all our cable accessories will always be insulated. Our 600 amp dead brake product line includes dead brake elbow kits, which include a standard 600 amp T-body, an unthreaded compression lug, a cable adapter, and a basic insulating plug with cap. The kits can also come with an ETP or elbow tap plug if a 200 amp tap is desired. We also offer junctions and tap masters. Tap masters provide a simple solution to take in 200 amp taps off of a 600 amp system with increased flexibility to operate and maintain the distribution system. Hubble Utility Solutions Cable Accessories product line also includes underground arresters. These arresters protect underground distribution systems from lightning and switching surges. Our metal oxide arresters are some of the highest quality in the industry, made in our Wadsworth, Ohio facility since 1978. Information needed to quote or order Hubble load break elbows and dead break T-bodies are very similar with a few distinctions. The voltage class, diameter of insulation, conductor size, and conductor stranding are the most important details. Additionally, it helps to know whether a test point is needed. Load break elbows have an integral seal option available, and dead break T-bodies have two options for connectors: compression and shear bolt. Other questions on cable accessories, application, or selection can be directed to the Cable Accessories Business Unit located in Aiken, South Carolina. Please feel free to reach out to your regional resource to address your needs. Once again, thank you for tuning in with Hubble Utility Solutions and Hubble Cable Accessories and Product Training 101. Tune in on the next training module to learn about the advantages of the Hubble Utility Solutions Cable Accessories line.